Today's section, 1-6, Introduction to Solving Equations, and today's learning goals should review some of the information you learned about equations in Algebra 1. So let's start with some properties that should be familiar to you. The substitution property. If A equals B, you may replace A with B in any true statement, and the resulting statement will be true. Now, A equals B looks like variables, but remember, A and B could be numbers, variables, a combination of both. Another vocabulary word that's used in this section is a literal equation. Literal equation is just an equation with two or more variables in it. The examples you're going to see will be formulas. Are examples of literal equations that you've worked with in the past. Other properties of equality that you've worked with. Again, we're not going to drill you on the names, but you should be aware of the properties and how they represent shortcuts in your work. So the reflexive property is just basically that number equals itself, A equals A. Symmetric property, if A equals B, then you can switch it around. B equals A. Transitive, if A equals B, B equals C, then A equals C. The addition property, if you have a true statement, A equals B, then A plus C has to equal B plus C because you are adding the same value to both sides. Subtraction property, same thing. If you start off with an equation, A equals B, and then you subtract the same value from both sides, you should have a balance or an equation that is true as well. Multiplication property, start with the A equals B, multiply both sides by a value C, and you should get equivalent equations. And then the division as well. So those are all properties you've worked with, and they allow you to manipulate our equations, so that's where we're going to start. This happens to be an example of a literal equation. The relationship between the Celsius temperature C and the Fahrenheit temperature F is given by Fahrenheit equals 9/5 C plus 32. Find the Celsius temperature that is equivalent to 122 degrees Fahrenheit. So we should first be substituting into the given equation that 122, that's a little big, let's make it small, 122 for F. Leaving C as the only unknown in our equation. Okay, we would subtract 32 from both sides to try to get C by itself. And in doing so, you can see we would have 90 remaining on the left-hand side. We'd have 9/5 C over on the right. We've learned that with our previous algebra work, that to get rid of a fraction, it's best to multiply by its reciprocal. So we're going to multiply both sides by 5/9. In doing so, that allows canceling. On the right-hand side, most of our numbers are gone, and we only have our variable C remaining. On the left-hand side, 9 goes into 9 once, 9 goes into 90 10 times. That leaves 10 times 5 for a total of 50. And 50 was equal to C, and C in this problem is degrees Celsius. So we took a literal equation, substituted in a value, and found its Celsius equivalent. If you don't have story problems, real world problems, you might have just generic equations. So to do this one, very similar, using your rules, we would take what we're given, decide which way we like to move things. Some of you have learned that variables on the left, numbers on the right, but that's not exactly standard everywhere. So as long as you get down and solve your equations so you have variables on one side, numbers on the other, you should be fine. We try to want to stick with one move per line. So on this one, we might do an add 8 to move the numbers all over to the right side. That would leave us with 3x equals 5x. A negative 20 plus 8 is a negative 12 remaining. Now we would move the x's to the same side. So that would mean let's subtract 5x from both sides. When we do that, it leaves us a negative 2x equals a negative 12. Seeing that we have multiplication, most people would divide on both sides by that negative 2, resulting in x equals 6. And then you always want to get in the habit of at least mentally, if not physically, checking these problems. It says check by substitution. So if we would check, we would take 6 and put it back into the original equation wherever there's a variable and make sure that the right-hand side equals the left-hand side. Otherwise, we know the value we came up with would not make the statement true. So continuing, 3 times 6 is 18. 18 minus 8 on the left-hand side. 18 minus 8 is 10. Going to the right-hand side, 5 times 6 is 30. 30 take away 20 remains. 30 take away 20 is 10. 10 equals 10, and it checks. So we know we verified that our solution x equals 6 is correct. You should get in the habit, again, on equations of checking them mentally, if not on paper, pencil, quick check to make sure you have an accurate solution. If we were going to be doing a solve the equation by graphing, what you'll want to notice is that you have a left-hand side and a right-hand side in this problem that really do nicely set up to your y equals mx plus b equation. So if you sort of substituted in your brain and said, well, one of the equations is y equals a negative 0.8x plus an 8.9. And then the other equation would be y equals 6.25x minus 3.36. You have two separate equations. So there's our equivalency. And this is sort of like the substitution, using the reflexive property, etc. To solve this. You would take both of those equations, punch them in to your calculator or by hand, but by hand, seeing the decimals here would make it a little tougher, into our equation. And when it says solve the equation, if we have two lines that do not have the same slope, because we have a negative 0.8 and a positive 6.25 for our slopes, we should be able to get two lines that intersect, and that point where they intersect, that ordered pair, x, y, where they intersect, so wherever our lines are going one up, one down, that point where they intersect is what we're looking for our solution. And then that xy value that you get should be able to be substituted in for x and in for y into both equations to see if you have your correct solution. So, solve the equation by graphing. First rewrite them, put them in, look for the intersection points. Last, we go back to another literal equation, one that you might not be familiar with, but you're expected to manipulate. So in this case, solve for v sub 0. So our initial velocity is what that v sub 0 usually stands for. And in this case, if we would solve for v sub 0, we would have to undo any processes so that we could get v sub 0 by itself. Looking at this one, we have our division going on, so that's probably the first thing we want to undo. So if we would undo and divide by t, I believe we should be timesing by t on both sides. When we do that, a times t has to equal our subtraction problem, v minus v sub 0. Two choices. You could move the v sub 0 to the other side so that we could get rid of the negative sign that's here, or you could move the v to the other side and later deal with the negative sign that's in front of v sub 0. And now I'm going to move the v sub 0, so we have a positive value. But again, it's your choice what you want to do. So if we would add v sub 0 to both sides, that leaves us the v sub 0 plus the at now equals little v. And now you can see very easily to get rid of the at, since it's addition, we would subtract at from both sides. And again, since we do not have common terms, like terms, we would have v minus at. There is no substitution, there is no numbers you would put in this case. It's just basically rewriting the equation to put it in another form, solving for a different variable. So those are your examples of problems you're going to be doing in this section. Come to class with any questions you may have, and especially if there's questions about the graphing part of it with your grapher, and we should be able to do the problems that correspond to these examples.